Today we're going to be looking at using Pythagoras' theorem. Now, as I've already said, it's something you do in Year 8. So you've already covered it. You've already looked at it. However, when we don't look at things for a while, we easily forget. So I'm actually going to go through two examples that deal with the two initial types of questions you'll do. One to do with the hypotenuse, the other to do with finding another side. So we can use Pythagoras' theorem, c squared is equal to a squared plus b squared, to find the shorter or longer side of a right angled triangle. I've got two examples. One's a more practical one. A ship sails 80 kilometres south and then 45 kilometres east. How far is it from its starting point? Or the second example, just find the value of x. We're going to do both these examples now. So to begin with the first one, when I see a description like that, I need to draw a diagram. Now, because we should be used to our geography, we should know straight away that north, we're going to pretend it always points up. And so we're going to have an east-west as well, okay? North and south. What the question says is, a ship sails 80 kilometres south. Now, it doesn't have to be brilliantly accurate as long as it conveys the information. Let's pretend that's 80 kilometres. So the distance along here will be 80. It goes down there. And I hope you use a ruler rather than me who's just doing it quickly for you. But then it travels east 45 kilometres. That's about half of that distance. What we have to do is find how far it is from the starting point, which was of course back here in the middle. So we're looking to find that length along there. Let's for now just call it C, because that will help us in terms of our Pythagoras' theorem. So what we then do, we write out Pythagoras' theorem. C squared is equal to a squared plus b squared. Always write the formula out. Just makes it much easier. You then know what you're substituting into. What we do know, we've got an A and a B. It doesn't really matter which one. As long as you know your triangles right, you can use them. So C is equal to 80 squared plus 45 squared. Now I'm hoping somebody's got their calculator out who can quickly tell us what 80 squared plus 45 squared is equal to.
8,425.
That's equal to 8,425. Well done, thank you. Now, when we get to this point, we know c squared equals that, but we actually want to find c. So, of course, we have to keep doing our work on the equation, and we find the square root of both sides. So I'm hoping somebody's got their calculator out and can tell me what the square root of 8,425 is.
90,000.
91 sounds better. So it's 91. With a question like this, when we get the answer to 91, what we do is need to write it in terms of the question. So the ship is 91 kilometres from its starting point. For question 2, it just asks you to find the value of x. So I've made that a little bit easier. I like to have the diagram so I can see it. Notice how in this diagram, it's not just sitting flat. It's sitting on a bit of an angle. That's just to keep you on your toes, of course. It's x millimetres along that side, 17 along that side, and then the hypotenuse, 32 millimetres. We know that our equation is c squared is equal to a squared plus b squared. When I substitute in this time, it's not going to be as easy because I've actually got the c. So 32 squared is equal to 17 squared plus b squared. Remember, it doesn't matter which one's a or b really. I notice that I've got to find b, which is on this side. To make it easier, I just take 17 squared away from both sides, and then I will have 32 squared minus 17 squared is equal to b squared. Again, someone with a calculator please, to tell us what 32 squared minus 17 squared is equal to.
735.
So 735 is equal to b squared. We then find the square root of both sides. So therefore b will be equal to square root of 735. So it's equal to 27.11 millimetres. We'll leave it like that because that's an approximation. Make sure you do your working. You should know how to do this sort of working to find these sorts of questions. But that's how we use Pythagoras' theorem to find the length of the side on a right angled triangle. Thanks.